let me share my screen. I hope everyone can see my screen.
Yes, we can see it.
Yeah. So guys, welcome to Surat MuleSoft Meetup 43. And the topic for today's meetup is service mesh together with API management. Uh, okay. So Pooja and Ankur will discuss about service mesh with API management. So let me start with safe harbor statement. Both the speaker and the host are organizing this meetup in the individual capacity. We are not representing any organization or companies here. Basically, this presentation is completely for learning purpose, and like we don't hold, even like organizer or presenter doesn't hold any responsibility whether the same solution will work for your business requirement or not. The presentation is not meant for any promotional activities. So recording of the this meetup you can find on like event page. We will upload to YouTube within 24 hours. You can ask question at any time. So basically there are multiple ways you can, like you can just ask the question in chat window. We will going to monitor the chat window. Then secondly also, like you can enable your mic and you can just pick up the question. Then finally, we require the feedback from you for the session. This is very important for the speaker as well as for the organizer to improve in the future, basically. Yeah. So myself, Jitendra, and like Nitish, we both are the organizer for this particular meetup. We will just skip the introduction for us. Then like speaker. So Pooja and Ankur is the speaker for today's meetup, basically. So like Pooja, like or Ankur, you can share your screen and you can take the session from here, basically. Like I will stop sharing.
All right. Thank you, Jitendra. Hey, everybody. This is my first Surat meetup. Surat is a very special place for me. My parents lived in Surat for some time, and I'm very glad I'm able to present and be a part of Surat meetup. I am a cloud integrations lead at Collabra, and I'm very passionate about APIs, about holistic integration practices, and that's one of the reasons that drives me to be part of meetups, be part of the MuleSoft community and the API community in general. And I'm happy to meet everybody. Ankur, do you want to go ahead and introduce yourself?
Yes. So, hi everyone. I am Ankur and I'm a lead software engineer at Collabra. I have a total 10 years of experience, and for the like initial few years, I was learning a lot of things, and I thought of giving it back to the community. So that's why I'm part of this MuleSoft community, and I'm doing a meetup for the first time. So it's a new thing for me, but I'm trying my level best to give it back to the community of what I have learned. So glad to be here.
Yeah. Thanks to Pooja and Ankur for accepting the opportunity to speak on the Surat MuleSoft meetup. So thank you so much for that.
Thank you. Pooja, you're on mute.
Okay, can you see my screen?
Yep.
Okay, all right. Thank you, Jitendra. And I was just saying I'm going to go ahead and start. Let's see. All right. So we're going to be talking about service mesh together with API management. Now, service mesh is all the rage today, right? Everybody talks about service mesh and everybody wants to use service mesh. And we're going to look at why service mesh is preferred and how did that evolution happen, right? From having systems that were not adhering to architectural principles to now having these systems which are disparate in different regions, cater to different domains, and then wanting a sort of a service mesh to unify all the APIs and bring in some sort of governance to it. So that's why, service mesh together with API management. Why service mesh together with API management, and what are the benefits, and what were some of the challenges that led to looking into service mesh and seeing why service mesh with API management would possibly be a great solution to some enterprises. So let's get started. Okay, you can still see my screen, correct?
Yes.
Okay. So we're going to go over microservices. What are the challenges we see with microservices? How service mesh can help? What is API management's role when you implement service mesh? And then building an app network on Anypoint platform and extending that app network to use service mesh. I'm sure you'll have looked at either this picture or something similar like this, right? This is a network which has a monolithic architecture. And if you zoom in and pick up any two systems, right, it's going to look very clean because, those two systems are talking to each other, communicating with each other. But when you step back and look at the whole network of communication and this API network, you're going to see that it looks like a tangled mess, and it is difficult to make changes to it. It's tightly coupled, and these are some of the problems that that led people to look at microservices. Essentially, microservices were born out of enterprises following architectural principles to architect, create, maintain enterprise networks and enterprise API connectivity. So companies creating applications the companies that used to create applications, right, in this type of environment, they used to struggle to deliver experiences that their customers expected. Now, no matter what business you are in, what you are trying to do, the end goal is you are trying to service someone. You are trying to cater to someone else's need, whether it's in the form of services, products, or something else. But you are essentially doing it for someone else. And to deliver that experience, you have to be agile. You want to be quick to respond to changes and quick to include any new and upcoming things that are there in your industry. And with this sort of a setup where you have tightly coupled systems, it's a mess to document, it's a mess to change, update. It's very hard to do that. And when you struggle to deliver experiences that your customers want, then you struggle as a business, and that's not very good. So what's up with microservices? We already know, right? They are the evolution of best practice architectural principles. And you, with microservices, you are able to build your applications, you're able to scale your applications, and you're agile enough to quickly adapt to customer needs. This particular slide here, it's basically a comparison. It's a comparison between how a monolithic setup looks like and how microservices setup looks like. With monolith, you have one large code block that has all the logic associated, right? You see it, there's like all the logic. If these geometric shapes represent the logic, then you have all this logic in this particular block, and it's brittle, right? It's hard to change, because if you have to make a change, you have to make a change everywhere. It's rigid. You essentially have to be very tightly coupled with the teams that are creating this, to ensure nothing breaks when you make changes. Redeploying such applications after code changes, imagine the amount of testing that you will have to do, the amount of planning that needs to go in if all of these needs to change every time there is a single line of code or a single service that needs to be updated. So it's essentially a large block of code. It's very hard to maintain, manage, etc. And then over here you have microservices, right? They are, you have smaller services that are unlocking key pieces of functionality. It's agile, it is flexible, easier to maintain. And so obviously, enterprises started moving towards this setup. Everybody did a sort of legacy modernization and moved from monolithic setup to a microservices setup. And the end product was that your teams could be independent, and you could have different teams simultaneously working on different aspects of your enterprise architecture, and have sort of seamless delivery without competing priorities or any sort of issues that could cost you in time, in terms of how fast or how impactfully you could deliver value to your customers. And then, so when you started having all these services that were working together, you had patterns, all these popular microservices patterns that emerged, so your customers could get the most out of their strategy. Out of their microservices strategy. So choosing to incorporate microservices just made sense, right? Because it's easy, it's agile, and then you have invested in design patterns for developing software that has so many advantages compared to your old monolithic style, but it comes with its own challenges. And let's look at what some of those challenges are. So naturally, you have small blocks of code, and you definitely need to enable communications between those small blocks of code that you have, so they can. It's a two-way communication, so they can deliver experiences, etc. So when you have that sort of intercommunication between services, you definitely need to think about the AAAs, right? You need to have access to all those systems that you need to communicate with. You need to implement some sort of authentication and authorization. So essentially, you're talking about making these systems and communications secure, and allowing them to provide sort of appropriate level of access, so these communications can happen fast. These communications can happen without a lot of errors, while you maintain security and integrity of your systems. So then you want to obviously control that traffic, right? That is coming in and going out. And when you talk about controlling that traffic, you're essentially talking about prioritizing your communication between these systems, and that needs some sort of management to prioritize all your inter-service network calls. And some of these paths between your services might not be available all the time, and that could be for various reasons, right? When you're designing a system, you look at what it is that you are trying to deliver, and you sort of create this SLA, and at that point your goal becomes to adhere to that SLA, which may mean certain systems are active only during certain times of the day, and that could be for cost saving, or you're planning some maintenance, or that could just necessarily be some sort of a security consideration you have taken, or a compliance, and whatever, it could be a legal compliance, your industry specific compliance. So obviously you need to prioritize, and you need to cater to ensure you are resilient, and you have sort of a reliable setup to manage failures and fault tolerance in these situations. And then you have all of these systems, right? So you have these systems, you have to enable communication between the systems, and then you are managing how these communications are happening. You are prioritizing. Obviously, you have to maintain and monitor those systems, because you need to make sure that whatever setup you have in place, that's working, and it's working to meet the standards that you have established for your applications. In microservices architecture, you have all of these systems. So naturally, you have many teams managing all these systems. And these silos often mean that multiple teams are working on it almost simultaneously. So there could be possibilities of having inconsistent policy enforcement, or inconsistency in governance. Or maybe they're not mature enough, and they have automated DevOps, but it may not align, right? Every team's DevOps setup may not align to the enterprise direction, and that could potentially affect your systems and how you are monitoring it. So these are some of the challenges that microservices have. And what have organizations done, right, to manage these challenges? A lot of enterprises bring in a custom flavor to governance, because obviously not everybody is at the same place in terms of their digital transformation. It's like the future is here, but not distributed equally. So some teams may have a semi automatic governance, and other teams may not have, and obviously that those custom flavors that you bring in, that custom code that you bring in, since it's not consistent, since it's not consistent throughout and applicable throughout your organization, you may have to have multiple tools or different policies or a plan to manage all of that. And this sort of complexity, it stifles innovation and agility. And that was the whole reason we moved towards microservices. We wanted to bring in agility, and we want to be able to innovate constantly, because unless you are innovating, you are not on top in your industry. You are a step behind. And to innovate, you need to have these composable building blocks. You need to make sure they're secure. You have to make sure that they allow for omni-persona support. And to make all of this possible, you need to have solid governance and security policies for your entire enterprise. And organizations now are seeing a challenge with doing that with just microservices. So that's where the service mesh comes in. So organizations moved from monolithic architecture to microservices architecture, and that was a natural evolution to improve agility, to bring in innovation. But now everybody is seeing issues with microservices. They're not able to step up to the plate, and everybody started exploring service mesh. And when it comes to service mesh, right, it is configurable. It is essentially an infrastructure layer, which is fast, which has low latency, and that's why it's fast. And it's designed to handle a high volume of network-based inter-process communication. And we already saw with microservices that that's what we need, right? We need a fast, reliable, secure way of communicating between different systems. And we want to ensure that that setup is manageable. And service mesh just brings that in. It provides critical capabilities, which include service discovery, which is very important, right? You need to be able to automate service discovery. It brings in capabilities of load balancing, so you can control your traffic, you can manage your fault tolerance better. It brings in encryption, so your systems are secure. Observability, traceability, all of this caters to that monitoring aspect of your systems. When you have these small composable blocks of code, composable blocks of system, you want to be able to monitor them. And then, of course, authentication and authorization is very important too. So let's look at, how exactly. I mean, we saw service mesh is great because it does all of this. It brings in security, it brings in monitoring, it brings in fault tolerance and quick communication. But let's see how exactly it does that to mitigate the challenges that microservices created. A service mesh, it's usually implemented by providing a proxy instance. Let me get my laser pointer here. So this is like a rudimentary setup to show you exactly, what it is minus all the organizational complexities. So it's implemented using a proxy instance, and that proxy instance is called a sidecar, and that handles inter-service communication. and that handles all your security related concerns and monitoring. Anything that can be abstracted away from the individual services itself. So that way, you have your development team who can just focus on developing support and maintenance for the application code itself. So naturally, they can be focused on bringing in that agility and innovation that your organization needs. And the operations team can maintain the service mesh and run the application. Let's look at the sidecar pattern a little in detail. So microservices within a given development or cluster, right? They interact with each other through this sidecar proxy. These are essentially reverse proxies. They are lightweight, and they are deployed alongside each service that you have, right? Each service process, and they are in a separate container. If you see here, it's on a Kubernetes cluster, and you have a control plane, and then you have these essential separate containers, and each of these containers have a side proxy and a service, and each of that side proxy is deployed next to that service or that process, whatever it is doing. And these sidecars, they intercept the inbound and outbound traffic. If you can see here, that's what the arrows depict. So they look at, they work to secure, right, your services and enable communication, depending on the rules that you have specified. And those rules are specified usually on this control plane. So the developer can configure and add policies at the control plane level. So, you're just applying it here, and then that takes effect and takes care of all the individual service containers you have underneath it. And that leads to abstraction of governance consideration from the service code. And regardless of the technology used to build that service code. So all your common policies that you want, right? Timeout implications, you want to talk about load balancing or service discovery and your AAA. All of this is managed there. And a service mesh is typically applied to a specific Kubernetes cluster, and it intends to make service-to-service communication reliable, fast. However, right, in the enterprise, you do have several services, but within a single domain, but you also have several services that have consumers outside of any one specific domain, such as web developers, web apps, mobile devices, and more. For example, if you look at your, say you are a airline company, then definitely you have like services catering to one particular domain. Whatever that is, maybe that's something that your internal teams are accessing, but also they are allowing or integrating with these other systems that allow for flight ticket purchases, that allow for beverage purchases, and other things. So and people usually want a seamless experience, whether they're on their mobile phone or they're on web apps, or maybe they're at the kiosk in the airport and they're trying to pay for their baggage, right? So This communication and this sort of integration, it transcends just one specific domain, right? You're now going outside of one specific domain. And that's where API management sort of comes in, because you can't really extend your service mesh beyond that specific domain. So with API management, you have API gateways that are protecting your north-south traffic out of a right? And any sort of security issues, and then you have a dev portal to make your assets, services reusable, and to accelerate and innovate for your future. And this is all for security, right? You want to apply best practices to your API gateway in front of services with external consumers. So great, you can apply policies to that one specific domain that service mesh caters to, but you also want to be able to apply this to an external consumer. And without that sort of a gateway level security or edge security, you could have malicious activity that directly calls into a service within a Kubernetes cluster and can easily obtain the identity of the cluster namespace or the service. So essentially, to apply policies, right? And that could be authentication policy, authorization policy to that external facing user. And you want to protect the cluster from all sorts of attacks that are possible. And while you're applying all these appropriate protections to external facing services, you still want to make sure you are catering to your developers. You are allowing these services to be discoverable so that your dev team can reuse microservices and avoid any duplication of business logic across multiple services. What does this involve? So it involves a centralized and secure location through which developers can publish and discover services to use it in the future, right? Let's look at this example. It's a banking example. And you have these different departments. You have mortgage, you have corporate banking, you have private banking, you have insurance, and it is very hard to say that all of this will be used only for the internal purposes, right? No, they are open to consumers, and that could be other businesses or individual consumers. And you don't want to duplicate efforts just because these services are used by different departments or exposed to different channels. So say you have sort of a internal setup with your service mesh that is accessing this account information and doing some sort of calculation on it. You don't want to duplicate that across all of these, so each of these can access that individually. You want to create one and have all of this integrate and communicate with that setup. You want to have microservices and a service mesh. Microservices, so you can have these small services that can be exposed to different channels, and then also a service mesh to handle all of your governance and traffic controlling and all that, all the good stuff. And when we think about all of that, especially when you think about having a API gateway where you can apply all these policies, where you can sort of control all this governance and have this monitoring set up while also enabling service discovery and ease of development, the one thing that comes to mind is Anypoint platform, right? Anypoint platform can really empower your business because it has a management provision where you can monitor, where you can take care of security, where you can bring in that sort of governance while you can create and deploy your assets on Exchange. You can discover those, and then you can deploy your applications that can be managed through Anypoint platform. So having this sort of a application network with Anypoint platform brings in all of that. It brings security. It brings in discovery. It allows you to be both agile and innovative. So this is how a application network with service mesh looks like. So you have internal and external APIs over here, and you have your Anypoint platform, which essentially enables you to have API-led connectivity for your microservices, where you can discover, manage, and secure your services. You have your Mule applications, and that could be a Cloud Hub, RTF. Maybe you have a hybrid setup, whatever that is. And then here you have a service mesh. So having this whole network, your service mesh set up with application network it is great because it solves all these challenges that you were having with microservices alone. It solves all the challenges you were having with service mesh alone, while giving you a unified platform to manage all of your innovation and all of your products, etc. We went over this. You can discover, leverage any service in your architecture. You can centrally manage and scale it. You can integrate it with existing continuous delivery, CI/CD, enable security by default. So essentially, irrespective of where you are in terms of your organizational maturity for integration, you can bring this in to sustain you at that level and then help you grow. So you can, if you are at a low maturity, it will definitely help you to move towards a medium or a high maturity setup where you have maximum adoption of your microservices, where you have an opportunity to continuously revisit your architecture, both your platform and your service architecture, to keep it up to date, to ensure you are enabling security by default. So, summary. We know microservices are important, but microservices alone are not enough for security and governance. And we know service mesh can solve many of those security and governance issues. But when you combine all of that together using a API management tool, it is possible to centrally manage and scale microservices. So you can worry less about bringing in this governance or management and focus more on innovation and agility. Thank you. If you have any questions, you can feel free to ask now. All right, I'm going to hand it over to Ankur. Are there any
Pooja, like Amit has asked, like slide 15, please. Can you show the slide 15? Like,
slide 15? Sure. Hmm, am I sharing? No. Yes.
so Amit, like, what you want to understand from the slide 15?
Yeah, hi there. Like, I want to understand that in this one, when we are configuring the Kubernetes cluster in service mesh, like what are the things we need to consider, like whether that service need to be, is there any requirements that we need to consider, which like services which need to be run in the Kubernetes cluster?
Amit, that's a great question. And it's a great segue for Ankur because that's what he's going to be talking about. He's going to be talking about Kubernetes and Istio. So would you mind if I hand it over to him so he can go ahead and explain how you go about bringing in this service mesh, and then if after he does his presentation, if you still have questions that are not answered, we can pick it up then. Is that okay?
Okay, okay.
Okay, great. Thank you. Anybody else? Any other questions? If not, I can hand it over to Ankur. Okay, great. Thank you. I'm going to stop sharing now. And Ankur, you can take it from here.
Okay, yep. Thank you so much. Let me quickly share my screen. Just let me know once you can see my screen and if you can hear me properly, and
Yes.
I'll start us off. Yeah. Okay, perfect. So I'm going to start by talking a little bit about Kubernetes. So Kubernetes is basically a portable, extensible open source platform which provides us clusters and containers where we can deploy our applications. So when you deploy Kubernetes, it will give you a cluster. Now, each cluster contains a set of worker machines. These machines are called as nodes, and these nodes host the pods, which basically contain the containers where your application will be deployed. There are a few advantages that I'll quickly go over for Kubernetes. So it provides storage orchestration, which means it can automatically mount the storage system of your choice. It also provides secret and configuration management. So you don't need to rebuild your image if you're updating any app configuration or if you're updating any secrets or anything. Then it provides a feature for automatic bin packing, so it can automatically place containers based on the resource requirement. Then Kubernetes is self-healing. So let's say a container fails, then Kubernetes has the capability to restart that failed container automatically. It also provides automated rollouts and rollbacks. So whenever we make any rollout and if there is any error or if there is any issue, Kubernetes can automatically roll back. uh, it can automatically roll back. Then service discovery and load balancing. So since Kubernetes gives all of each pods their own IP address and DNS, it can manage them very well, it can load balance them very well. And now moving on to the next part, next prerequisite, I would say, which is Minikube. So now Minikube is basically a local Kubernetes setup that you can use if you have to uh, do some testing or if you want to develop something locally. So it's based for Windows and you can use Minikube. So it is a very simple tool. I'm going to show a few commands also in some while. So the only thing that you need for Minikube is Docker or a Hyper-V or any virtual machine environment. You can simply download a executable file and it will install your Minikube. The minimum laptop requirements, like system requirements that you are going to need, is two CPUs or more, 2 GB of free memory, 20 GB of free disk space, internet connection, and then again a container or a virtual machine manager such as Docker, Hyper-V, Hyperkit, KVM Parallels. Then if you have a look at this screenshot, so this screenshot is from Kubernetes Dashboard, which is accessible through Minikube. So I'm going to show all these things once I am done with the slides. Then the next part is Istio. So Istio is basically the open source service mesh that Anypoint Studio is using, Anypoint platform is using for this entire thing. So Istio has two components, data plane and control plane. So data plane sets up the communication between services. Without a service mesh, the network does not understand the traffic being sent over. So data plane is a very important part of it. Then the second part is control plane. So control plane has a few functions. So it takes your desired configuration and its view of the services, and it programs the proxy servers dynamically. Then it also provides an abstraction layer over the cluster management like Kubernetes. So Istio provides an additional layer on top of Kubernetes. So using this additional layer and using Anypoint, like the features provided by MuleSoft, we are designing this complete service mesh thing. Then this control plane runs on Kubernetes, and you can add applications deployed in that cluster to your mesh, extend the mesh to other clusters, or connect VMs as well. So let me show you a few things. You guys can still see my screen, right? So now uh, let me first run this command because it is going to take a minute to start up. So it's a very simple command, minikube start, which is going to start my Kubernetes cluster. While it starts, so the basic requirements are either Hyper-V or you can have Docker desktop as well. So if you want to see Hyper-V, Hyper-V is a part of Windows features, so you just need to enable that Windows feature and you will have Hyper-V setup. Otherwise, you can simply have Docker desktop installed. That is also going to help you out with your Kubernetes. So once this mini cube starts, we will be able to see all the nodes or pods or services. Then I'll take you through the dashboard as well. So let's give it 1 minute. So one more thing, just to note, it's that I'm using a normal command prompt as an administrator, because Hyper-V and Docker or whatever Windows container that we use, they need admin privilege so that they can work properly. So you can see that it is already automatically taking up Kubernetes image, and it is mapping those Kubernetes image into Minikube so that I can use. Now, once my Minikube is started, I can use this system with normal Kubernetes cluster commands. So if you want, we can see all the nodes. So I have one node Minikube which is ready. It contains, like, it has the roles of control plane and master. Then if I want to see pods, then I can also see the pods. So you can see I have, so one is default. I'll take you to this default application later. Then we have a few pods for Istio system that we can use for this service mesh. Then there are some pods for Kubernetes, like for example API server, controller manager, proxy, scheduler, storage provisioner, everything. And then we have the Kubernetes dashboard. Okay, now if required, we can also have a look at the services here. Get services. So it is going to show all the services that are available. So one is Kubernetes, second is Hello Minikube. So Hello Minikube is basically one of the applications that I have, like one of the images that I have deployed on my Kubernetes cluster, which is based on this IP. Then Minikube also provides us access to a dashboard. So I can just simply write Minikube dashboard and press enter. So it is going to take like 30 seconds and it is going to open a dashboard for me. Okay, great. Not even 30 seconds. So now you can see it has opened a Kubernetes dashboard for me where I can see running application, then pods and replica sets, everything. So you can see I have a Hello Minikube application running. There is one pod available which is running, then replica set. Then I can also look at a lot of other things available here. For example, if I want to have a look at the services, so I can see that there are two services running, Hello Minikube and Kubernetes. So basically Minikube is something that provides us with everything that we want to do in Kubernetes. And once I have Minikube installed, I can basically just run the usual Kubernetes commands that will be understandable by the system. Once I am done with everything, the only thing, like if required, I can stop my Minikube application, or I can pause it, or if I want, I can delete it. So it provides all the functions that a normal Kubernetes system like service should provide you. Okay, let's come back here. Okay, fine. Um, any questions? Let me quickly come back here. Amit, did I answer your question, or is there something else you'd like to see?
Actually, my question is, um, for a scenario like there are old services or the legacy service which are already running. Okay, so with MuleSoft, what we do, like if we want to do any transformation, we do, and we just publish in the MuleSoft and try to assess with the new transformation and the new functionality. But if we want to use the legacy services, so I feel that over there we can use the service mesh and um, like whatever the legacy which we can use, we can put in the Kubernetes and we can use that. Is this the correct, or like we should use in certain other scenarios? Like that's what I want to understand. In which scenario we should go for the service mesh in the Kubernetes?
Okay, so let's say you have some legacy applications as well, and you want to manage them or use them with Anypoint Studio. So for that also you can use this service mesh. So you won't have to do any extra configuration, but you just need to put it on the cluster, and that should be like good enough.
But the whole
And
point of bringing in that service mesh is to abstract out your security and governance. So make sure it follows those patterns, you know. So this, what I'm trying to say is, say your legacy system is too tightly coupled. There's no point in bringing that over to a service mesh setup. While uh, it's essentially, you know, if you have a broken wall, you're trying to paint over it, and that crack that is there in the wall, it still remains, right? So it's sort of like that. So unless you have already made your system robust, and then you're bringing in your service mesh flavor to it, then that's great, because that's essentially right there a transformation. But if you're bringing in your tightly coupled systems and trying to put them on a service mesh, you will not be able to reap in all the benefits of having service mesh setup, and it may be expensive for you, and just managing that might become a nightmare. Just be mindful of that. But yeah.
Yeah. So yeah, we have one more question in the chat window. So uh, can you check that, Pooja or Ankur?
Okay. Do you see any overlap?
The key benefit of bringing in service mesh is just that you are trying to abstract your whole what do you call it, your policy and governance, and you're trying to bring in sort of like a circuit breaker pattern to your system to make it more robust. I mean, RTF, having RTF is great, but again, it's just you have sort of microservices, and you're just deploying that on a runtime fabric. For some organizations, that may be enough. But again, if you're looking at integrating that to move towards more of a hybrid setup, then service mesh definitely brings a lot of benefits to those implementers, or those organizations, compared to someone just who has RTF. But in all, with service mesh, you're trying to bring in more sort of governance and fault tolerance into your network. I don't know if that helps. Do you have a specific use case you would like to share, or have you had any experience or sort of challenges where you have RTF, microservice architecture using RTF? Darshan?
Okay, you were saying like not really, just wanted to get a perspective.
Okay,
Okay, guys,
perfect.
I have two more questions if you can give some overview. So like, for example, if a client said that okay, he want to see both the perspective, whether to the RTF, whether to the service mesh. So the pricing wise, how is the service mesh? Is it expensive, or is it like how is the overall pricing for the service mesh?
It really depends on what sort of license you already have with with MuleSoft, and I don't really want to talk about pricing. But in terms of essentially having just RTF or having RTF plus microservices, I would look at what it is, what direction you are moving towards in the future, and look at your enterprise architecture as a whole to sort of come to that decision. Because say you have multiple tools, right, in your organization. You are a large organization, you have multiple tools that are doing integration, and then you're using this just for a very small subsection of compared to your entire organization. Then at that point, you have to really look at it and see, having a service mesh, will it enable you to abstract all of those cross-cutting concerns, or move those responsibilities for concerns with regards to service-to-service communication and resiliency outside of those microservices into a service mesh layer, right? Because that's the key component you're trying to bring in there. It's a proxy, and it's and in a cloud native application, it's typically co-located with each microservices. So if it benefits your whole enterprise as a whole, then why not? But if you're looking at it through a narrow scope and trying to bring it just for a very small section of your integration, then I would definitely talk to the MuleSoft representative to get the cost, so you can make a more informed decision. Eventually, right, where the whole IT industry, the forecasting, the trends for our industry, everybody is moving to have what do you call it, to bring in automated intelligence, right? Everybody is looking to automate their services, and it makes sense that we are going to have all of these cross-cutting setup, where you are going to have your local microservices interacting with your cloud services, and you are exposing a lot of your APIs and whatnot to outside consumers, to external consumers, because that's what has been. It's been sort of a data revolution, right? Everybody is looking at this data to build their business, and you're bringing in data-led insights. So naturally, the next step is to monetize all of this, to bring in that API economy, where you're making money, and that could be tangible or intangible sort of monetary benefits you're deriving from your API, right? And that 9 times out of 10 involves exposing your APIs to external consumers. That may be external consumers who are users of your products, or external developers. It's still sort of external consumers. And then on the other side, you may want to ensure your internal services are fast and reliable. So looking at that, I think anybody who at least sets up their API management or decides to pick and choose a API management platform that can manage both your microservices setup and your service mesh setup, is going to be a great investment, because that's going to definitely help you be more innovative. And I think through this presentation, that's what we are trying to communicate. That service mesh alone may be great, but having service mesh with a solid API management platform is the best way to embrace this future we are all moving into. Where your sort of a choice or a decision or a debate lies between do you just stick with RTF or service mesh, I think that's a more concentrated and a narrow decision. It's going to be very specific to your use case, very specific to your organization, and very specific in terms of what sort of budget you have to encourage this sort of setup, and not necessarily a discussion with regards to having the service mesh with Anypoint platform management, API management platform. So I don't know if I helped you, but I think I would look into having that discussion with the stakeholders, finding out what is the problem that you are trying to solve, and then see if service mesh with your RTF makes sense. But if you are going to bring in service mesh with RTF, it better be with a good API management tool rather than just a service mesh and your microservices.
It's okay. Actually, I want to get I want to know that, okay, how much it cost to do the setup for the service mesh, but it's okay.
Yeah, you will have to talk to your representative. I don't know if Jitendra, are you there? Do you know? For me, it depends on every customer. I have never seen a uniform price. What about you?
I think so basically for costing or licensing purpose they have to contact their enablement manager basically.
Yeah.
So yeah, so like we should not talk about this costing and licensing. So generally like they have to contact their like MuleSoft representative, basically their organization MuleSoft representative for costing purpose.
And like apart from Istio, like is there anything else like Kong Mesh or Linkerd? Is there like, or just with the Istio we can use the service mesh, or is there any alternatives also?
I think Istio only on MuleSoft, right, Pooja? It's Istio only.
Yes.
Okay.
And other thing
Yes.
like what I think like why this service mesh introduced by MuleSoft, because because there might be some non-MuleSoft microservices running Kubernetes cluster. So to enable the API management for that, right? So that's why MuleSoft has come up with the concept called service mesh, on the Anypoint platform. That is also one of the use case basically. Like you have some microservices, might be Spring Boot based microservices running in the Kubernetes cluster, and if you want to enable your API management capability on the top of those services, so you can use that service mesh basically. So that is also one of the use case.
And
Also, MuleSoft has unified gateway, so any other tools you have to can be managed, but unless we have a specific use case, it needs to be looked at on a case-by-case basis. I'm sure the Kong setup that you have, it exposes that your services or your data somewhere, right? At that point, you just decide what your control plane is going to be, and then integrate with that. How exactly, off the top of my head, I can't say because it's not general, it's very specific.
Okay, thanks guys. Any demo today, like for the proxy? Any proxy in the service mesh? Any demo?
No demo.
Okay.
We can do a demo, maybe another meetup.
Okay. Thanks guys.
So anyone have any other question? So Pooja and Ankur, have we done with the presentation?
Yes, we
Yes.
are.
Yep.
So yeah, so thank you so much, Pooja and Ankur. It was like a great session. So like it gave a great overview on like how we can use the service mesh and Anypoint platform together. So it was overall a great session. Thank you so much, Pooja and Ankur, once again. Yeah.
Thank you.
Thank you. Yeah.
So Nitish, are you in the call?
Yes, Jackie, I'm here. Am I audible?
Yeah. So Nitish, you can run your quiz. So I
Okay,
will just go on mute.
sure. First of all, thanks Pooja and Ankur. It was really informative session.
Thank you.
Thank
Yeah.
you.
So let's go to quiz quickly. I'll share my screen. 1 second.